In today's video, we are going to be looking at angles in standard position. So one thing that we have to remember, one thing that is this right here. This line is our terminal arm. So where this graph terminates. If we have a point right here, this would be maybe point P, X, Y, right? This is going to be called our terminal point. And from the origin, which is right here, to our point, we have R. So that is called R, that line. There is also represented with R. So one of the other things that we have to remember is our coordinate plane has 4 quadrants. We have 4 quadrants on this coordinate plane. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 is from 0 degrees to 90 degrees, right? So that's why it's right here. Quadrant 2 is from 90 degrees to 180 degrees. So whatever our terminal arm is in between 90 or 180, that's going to be in quadrant 2. Whenever our terminal arm is in between 180 and 270, that's going to be quadrant 3. And whenever our terminal arm is between 270 and 360, this is going to be quadrant 4. Something else that we need to take note of would be our reference angle. So in quadrant 1, our reference angle, or our theta reference, that's how we write it, is the same as theta. In quadrant 2, our theta reference is 180 degrees, subtract our theta. In quadrant 3, our theta reference is theta, subtract 180. Notice that the position is different. And in quadrant 3, our theta reference is 360, subtract theta. Okay? Now, if you want to find theta instead of theta reference, in your quadrant 1, your theta is going to be theta reference, same thing. In quadrant 2, your theta is going to be 180, subtract theta reference, right? In quadrant 3, however, your theta is going to be 180 plus your theta reference. And then in your quadrant 4, it's just going to be 360, subtract theta reference. It's going to be the same thing, kind of just different a little bit. So another thing we have to also remember is our C.A.S.T rule. And our C.A.S.T tells us where cos, sine, or tan, or all of them are positive. So in quadrant 4, so this is how you write your C.A.S.T. You don't start from quadrant 1 and start from quadrant 4. So it's C.A.S.T. Your C starts from quadrant 4. It means that in quadrant 4, your cos is going to always be positive. Quadrant 1, all of your trig ratios, all of them, so both cos, sine, and tangent are going to be positive. In quadrant 2, only sine is going to be positive, and in quadrant 3, only tan is going to be positive. So it means the rest are going to be negative. So that's what C.A.S.T is. So these are the basic things that we need to remember on our coordinate plane. So we just needed that refresher. Okay, so here we have a graph. I'm going to just draw an angle right here. And this is theta is going to equal to 36 degrees. What will our theta reference be here? We know if we go back to here, we see that our theta reference is the same as our theta. So if our theta is 36 degrees, our theta reference will be equal to theta, which theta reference would also be 36 degrees. So here's another question. We have this graph right here, and we're asked to find our theta reference. One thing that you need to know to help you with your reference angle is always the side that's closest to your x-axis. So what that means is, I'm just going to draw a handwritten graph here before we do that question. If you have your terminal arm and you're in quadrant 1, whatever this is your theta reference, because it's the closest that angle is the closest to your x-axis. If you have an angle right here, right? And again, this is also your theta, right? Because that's an angle. This is going to be your theta. Let me just get this out. Okay, if you have an angle right here, this right here is going to be your theta. But it's not going to be your theta reference or your reference angle. Your reference angle is always going to be the angle that's closest to the x-axis. So this right here is going to be your reference angle. Okay? Another thing that we need to know is, let's do another one when it's in quadrant 3. Again, this whole thing right here is your theta. All the way to the start is your theta. But your theta reference would just be this little portion in here. So that would be your theta reference. That's the closest to the x-axis. We can't go all the way here because that's like way more, but it's closest to the x-axis that way. So this is going to be your theta reference. And so these equations that I have here, where theta reference is 180 degrees minus theta. Again, we're going to take the whole, remember if our angle was right here, we're going to take the whole thing, we're going to take away theta, which is this angle right here, right? To find that, I'm going to come back here. So for this one, when we have our theta reference is theta itself, and we're going to subtract 180, you can see that it makes sense because this is theta right here. So we're going to take the whole thing and we're going to subtract 180. So just that, right? Just this right here to get this, right? That makes sense. And so when we're looking at this in quadrant 3, so if we have an angle right here in quadrant 3, this whole thing right here is our theta, but just this is our theta reference. And so the equation that I gave makes sense because to find this theta reference, we're going to have to take the whole 360 and subtract our theta, sorry, not theta reference, and subtract our theta from the whole 360 to find our theta reference. So that's why those make sense. So in case you forget the equation, you can just try and figure it out on your own. So here we go. So now we have this right here on the left side of your screen to figure out what the theta reference would be. Now this, the first thing to know is what quadrant it's in. So this is quadrant 4. This is in quadrant 4, and we're trying to find this angle right here, right? This is theta reference. So to find theta reference, again, we're going to take the whole 360 angle and subtract theta. That's how we're going to find that little spot right there. So theta reference would be 360 subtract our theta. And our theta reference would be 360 subtract 321. And our theta reference would be 39. Right, so right here, 39. So that angle right there is going to be 39 degrees. So that is it for this video. I hope you guys learned something, and I will see you guys in the next one. Bye.